Hi, I'm Martin Newell and this is my B-25 Mitchell Bomber 1/48 scale. And the purpose of this movie is to show you some of the internal mechanisms under the covers. So to do that, I'll just remove the nose section here, this one-piece Durabatics nose cone, and to get inside. First up we have the receiver here, which is a rabbit receiver that I make. This particular one is 8 channels using the Hip-Hop 2 second generation Hip-Hop operating system. That provides the 8 control channels as well as a strobe for the flashing nav light up here. This big block here is the plug block into which all the servos are plugged, and also the lights and the wingtip lights are plugged in there as well, and the motors. The electronic speed control for the motors is integrated with this plug block. For the servos, we have the aileron servo on top here. This is a Nicolecti servo. I chose that one because I wanted the push-pull nature of that servo for the ailerons. Underneath we have in here the elevator servo. This drives both the elevators at the back as well as the brake mechanism on the main wheels. Underneath here we have the flap servo, so that can go half down, full down on the flaps. And the slow travel of that is controlled by the transmitter. On top here we've got the bomb drop mechanism, which actuates the bomb drop in here. Then over the other side we've got the rudder servo tucked in there, and that drives both the pair of rudders at the back through a bell crank mechanism as well as the steerable nose wheel, and I'll show you more of that in a moment. And then finally, back on this side we have the custom retract servo. That's a custom servo. Reason for that is because I wanted a 1-inch throw, much longer than you can get on normal micro servos, and it's got a much bigger gear ratio, so I got much more force out of it as well. So I get something like 6 times the force that I can get out of these other servos, and that drives the retracts on the main gear as well as the nose gear. So, speaking of retracts, let's look at the nose wheel. The nose wheel retract is operated through a cam follower running in this W-shaped slot here, and so if I actuate the nose of all the retracts, you can see that cam follower running along that slot into the full down position. And the reason for this slot is that there's a lever inside here joined to the nose wheel, and when the nose wheel is in either full down or full up position, the cam follower is in this 45-degree slot, and that completely locks the nose wheel. There's no force back on the servo over here. The main wheel retracts, I'm afraid you can't see the details of those. They are a slightly different mechanism, but nevertheless they lock both up and down. But one thing you can see back here on the main wheels, if I bring those back down again, is the brake mechanism. The brake is a simple pad that rubs on the outside of the rubber tire, and it's actuated by full down elevator, so I can actuate that, and it's a little sandpaper block that just rubs on the rubber and sort of self-locks as the wheel tries to go forwards. Turns out to be quite effective. So let's take a look now at this side and how the retract mechanism interacts with the steering mechanism. The nose wheel is fully steerable, of course, and that has to work with the retract. So to show you that, I'll just put this into an automatic mode where the rudder is now being oscillated back and forth, and while that's happening I will retract the nose wheel and watch what happens to the nose wheel steering. As the wheel goes up, the amplitude of the motion of the nose wheel gets less and less until when it's fully retracted there's no motion. This is done through a lever mechanism. There's no sliders here or disconnects or anything. There's a lever here with a universal joint on the end and another effective universal joint at the base here, and in this position, fully retracted, this lever is having no control on the nose wheel, but of course the rudders are still functioning. As the nose wheel comes down, watch what happens to its amplitude. It gets more and more and more until when it's fully down you get full amplitude of motion on the nose wheel. So that's pretty much what I wanted to show you. Thank you for watching.